So, if you study hard, you'll get the job. True or false? Well, that actually depends. And by the end of this video, you'll know exactly how to figure it out, using the power of logical reasoning. Today we're diving into a topic that many people find tricky, but I promise, after this chat, it's gonna make way more sense. We're talking about simple and compound propositions. This stuff is super important if you really want to understand logic. And hey, if you're preparing for job interviews, especially in tech, finance, or any field that loves analytical thinking, this material is pure gold. So stick with me until the end. Oh, and quick reminder, hit the like button, share this with your friends, and turn on notifications. By the end of this series on propositional logic, you won't have headaches with logic questions anymore. Trust me. For those of you just tuning in, I'm João Sarubi, professor of discrete math, and today we're exploring the world of proposition. Let's start with the basics. So, what are simple propositions? Simple propositions are like the building blocks of logic. They can't be broken down into smaller parts. They are complete statements that express just one idea. Here are some practical examples. 2 plus 2 equals 5. It's false, but it's simple. The earth is blue. That's true and simple. All humans are mortal. True and simple as well. See, each of these sentences expresses one idea. You can't split them into smaller parts that still make sense logically. Now, what about compound propositions? This is where it gets interesting. Compound propositions are like recipes. You take two or more simple propositions and connect them with special ingredients called logical connectives. These connectives are and, or, XOR, if, then, and if, and only if. Let's check some quick examples. With and, Michael is the teacher and Sarah is a doctor. So for this sentence to be true, both parts have to be true. Michael really has to be a teacher, and Sarah really has to be a doctor. If only one of them is true, or if none of them are, then the whole sentence is false. Now with or, I'll go to the grocery store to buy oranges, or I'll go to the pharmacy to buy medicine. With or, the sentence is true if at least one part is true. So I could go to the grocery store, or to the pharmacy, or even to both places. As long as I do at least one of these things, the statement is true. It only becomes false if I don't do either. What about XOR? This one's different. I'll go to the movies XOR, I'll go to the theater. Here's where it gets tricky. For XOR to be true, exactly one part must be true, but not both. So I can go to the movies, or I can go to the theater, but I cannot go to both. If I go to both places, or if I go to neither, then the statement is false. Here's a conditional example. If it rains, then I'll go to the movies. This is interesting because it's only false in one specific situation, when it rains but I don't go to the movies. In all other cases, if it doesn't rain and I go to the movies, if it doesn't rain and I don't go, or if it rains and I do go, the statement is considered true. And finally, the biconditional. I'll pass the course if and only if I study. This creates a two-way relationship. For this to be true, both parts must have the same truth value. Either I study and pass, or I don't study and don't pass. If I study but don't pass, or if I don't study but somehow pass anyway, then the statement would be false. So, how do you know if a compound proposition is true? Here's the key. You need two things: the truth value of each simple proposition and which connective is linking them. Once you've got that, you can decide if the whole statement is true or false. It's just like solving a puzzle. And hey, if this is helping you understand logic better, don't forget to subscribe and give this video a thumbs up. It really helps the channel and tells me you want more content like this. Now, let's talk about the magic of truth tables. Think of them like a map of all possibilities. Say we have two propositions, P and Q. They can be both false, false and true, true and false, or both true. The truth table lays out every combination and shows the result of the compound statement in each case. Fun fact: truth tables are directly connected to binary numbers. If we replace f with 0 and t with 1, the combinations become 0, 0, 0, 1, 1, 0, 1, 1, which are literally the binary numbers 0, 1, 2, and 3. Pretty amazing, right? Here's a golden tip. The number of rows in a truth table always follows the formula 2 to the power of n, where n is the number of simple propositions. 2 propositions, 2 squared equals 4 rows. 3 propositions, 2 cubed equals 8 rows, and so on. This pattern keeps your reasoning organized and makes sure you don't miss any possibilities. So, what's next? In the next lesson, we're going hands-on. I'll teach you how to build truth tables from scratch, and we'll break down each logical operator with examples. You'll see how it all connects beautifully. Until then, start practicing. Look for simple and compound propositions in your daily life. You'll be surprised how often they pop up. See you in the next one.